4 valves. 2 semilunar valves and 2 cuspid valves. Bicuspid, tricuspid, pulmonary semilunar, aortic semilunar. Those are the valves which control flow, right? It's got to. So that's the general architecture of the heart. Just a couple of more subtle things here than you'll finish with the heart. You can see on these valves, you can see this clearly in the sheep heart. You can actually see it in the calf heart with its heart. It's kind of cool to see. Anyway, these little flaps are anchored into the heart muscle with little strings, heartstrings. That's what we just call them in general. But these little strings are called chordae tendineae, the heartstrings. It's either on this side or on this side. And they're anchored into the heart by structures called papillary muscles. Now, I think this is pretty cool, because what these little heartstrings do is they make sure that the valves close precisely, right? Because look, when this thing contracts, blood's going in this direction, and these little cusps also have to close firmly. It's kind of like an umbrella in the wind, that can blow inside out. Well, these little strings keep the cusps under tension so that when this thing contracts, the valves close precisely. They don't blow backwards, say, into the atrium. And that's not good, right? Because then blood's going in the wrong direction. So the chordae tendineae are the little strings which exert tension on the heart valve. Now, only the bicuspid and the tricuspid valve have chordae attached to them. The semilunar valves, no problem there. They said papillary muscles anchor the chordae tendineae, which are attached to the valves. And those are in our models, and you can see in the sheep hearts really well. Other one, there's a little septum, between the sides. That's easy. The only other one on here, you see how the heart muscle, and you can see this on the sheep heart, if you kind of, with your hands, you kind of like put a little tension on it and sort of open it up. It's got this webby appearance to it, and the webby appearance to the heart muscle is called the trabeculae carnae. I guess meat, I don't know. Right? Trabeculae carnae. There you go. So that's pretty much the heart. Maybe you've heard of a medical condition called mitral valve prolapse, which is kind of a bad condition. Because on the mitral valve on this side, this is the high pressure side of the pump. And sometimes these heartstrings get a little loose. And the valve, instead of closing precisely under pressure, kind of blows backwards. And blood then can back up into the pulmonary side. A prolapsing mitral valve is a problem. That's going to need some surgery to correct that. So the valves sometimes have problems and need work. It's just like valves in a car, I guess. So all the rest of these arteries and veins that are branching off up here, we'll get to those. There's a couple other structures I haven't mentioned, the ligamentum arteriosum, the fossa ovalis. I'll get to those probably tomorrow night. Those are structures related to fetal circulation that are just remnants in an adult heart. I once had some free time on my hands, I don't know how I did, and I decided to see whether or not sheep hearts have this little thing called the ligamentum on them. I was told that they did. And so I spent a lot of time dissecting the sheep heart, and I really actually did find it. I don't try to find it anymore, but it's on our, it's on these hearts. So for example, see how there's this little kind of, little connector here between the pulmonary trunk and the aorta? That's this thing called the ligamentum arteriosum. It's a remnant of our fetal circulation. And there's another thing here called fossa ovalis, which is also a fetal thing as well. Anyway, so that's what the heart looks like on the inside. And this is just the description of what I just said. So if I ask you to trace the flow of blood through the heart, you'd be no sweat. It's really easy to do. Comes in the right side, goes out to the lungs, comes back into the left side, and goes to the rest of the body. It's that simple. And here's the other side. Systemic circuit. So that's really simple. This picture, this is from your book. It's just a blood flow diagram. about tugging at someone's heartstrings, I think something like that. So they actually do exist, although nobody ever tugs at them. These are just the anchors that limit the motion of the valves. Pretty cool. Pretty neat pump, I tell you, it's a pretty cool pump. Pretty good pump, man. Never gets tired. Pretty amazing. This shows you the strings. There. Just kind of don't have any tension on them, and then this closes, and the tension builds up on them. You see this strings there. And what else? Yeah, coronary circulation. I'm not going to talk about coronary circulation tonight. Coronary circulation is the actual circulation to the heart. And if you've ever heard of anybody having like a quadruple bypass surgery, that means they have crummy coronary circulation. And you've seen the things on TV like they're doing like this imaging of somebody's like vessels on their heart, and they put the dye in, right, and it kind of spreads around. And then the heart surgeon, this is in real time, will look at the picture of where the dye is going into the coronary circulation, and they'll go, ooh, look, right there. You see, that coronary artery is like 90% occluded. And if it gets any more blocked, then the blood's not going to be able to get past the roadblock, which means that heart muscle that's being supplied by that vessel is not going to get blood, and it's going to die. That's a heart attack, right? So they're thinking, well, you know, geez, this doesn't look too good. We're going to have to get you in here as soon as possible for, ooh, you got 4 coronary arteries, and 3 of them are just about clogged. We're going to bypass 3 of those things in. And by the way, when you get out of the hospital, you're going to have a new diet, okay? Get rid of that red meat and, you know, everything else. So, and sometimes it runs in families, you know, and stuff like that. My dad didn't. I'm just going to say my dad should have died of that. I mean, he didn't.